The last piece of our route overlay class is to override the draw method that we inherit from the overlay class and to define what needs to be drawn on top of the map. Now, as you can see, this method receives three pieces of information: a canvas that we use for drawing purposes, the map view that we're going to be drawing an overlay on top of, and a Boolean called shadow. And this Boolean variable receives obviously a true or a false value, and what actually happens is this method gets called twice. Once with the Boolean value true to say to draw the shadows for whatever the overlay is displaying, and then once with the value false. And the way this is typically used, for example, if you ever go search with Google Maps, you'll often see that it places pins on the map, and those pins usually cast a shadow. So if you want to take advantage of that, you could check for the value of the Boolean and then draw the shadow in one case and draw the actual overlay information in the other case. Now, in our case, we simply ignore the shadow argument. We're going to draw the path that we take as a graphics path object, so we create a new path and we set the location variable previous to null because as we first get started there is no previous location. Then for the current set of locations that we have, we walk our way through those locations, getting each one at a time. From the location, we're going to create a geopoint using techniques that we showed you previously. And then the next thing we're going to do is convert that geopoint into a screen location. And to do that, we create a second point object, a regular point object, not a geopoint. And we go to our map view and get its projection object. And you can see here by hovering over get projection that it returns to you a projection. And basically this helps us convert between geographic coordinates that are represented by latitude and longitude to pixel coordinates on the screen. So once we have the projection, we can call its toPixels method, passing in the geopoint and the point object where we want to store the actual screen location, and it will convert the geopoint into a screen location that can be drawn with on the screen, on the overlay I should say. Now, if there is a previous location, what we're going to do is add a new segment to our path from the previous location to the current location. If there is not a previous location, we'll simply move to that point that is specified by the new screen points x and y coordinates. So assuming that we have a previous point, we will then go ahead and get the geopoint for the old point, convert that to a screen pixel point object, and then draw inside of our path, I should say, place a new piece inside of our path using the quad to method from the old screen point to the new screen point. And basically this is going to allow us just to add a new segment to our path. If by any chance the current index is divisible by position marker, that means that we have gone 10 locations, and we also want to draw a circle with the canvas, so we place a circle on the canvas by calling draw circle. And then finally we set location previous to the current location, and at the very end draw the path using the path object called new path that we've been configuring in the loop up above. So at this point we've now drawn whatever number of dots represent the locations we've gone through so far. Again, every 10 locations we draw a dot, and then on top of those dots we draw the path using the canvas object's draw path method.